In this video, we are going to learn about the unit circle. So the first thing we need to talk about is what the different trig functions are in relationship to the x and y axis. So cosine is the x coordinate, sine is the y coordinate, and then your tangent is this ratio of your sine over your cosine, which would be the ratio of y over x. Secant is the reciprocal of cosine, so it'd be 1 over cosine or 1 over x. Cosecant is the reciprocal of sine, or 1 over y. And cotangent is the reciprocal of tangent, which would be cosine over sine, or x over y. When we think about where our different functions are positive versus negative. So all functions are positive in this first quadrant. Sine is what's positive in the second quadrant. Tangent is what's positive in the third quadrant. And cosine is what's positive in the fourth quadrant. So there's a little acronym that helps us remember this. ASTC is all students. Let me rewrite this a different way. So all STC. So A is all, and then the S is sine, but we could say all students take calculus. And that's kind of like a mnemonic device to help us remember ASTC, all sine, tangent, cosine. All right, so in the second part, they want us to use the unit circle to evaluate the following. So cosine of 270. So if I think about where 270 is, it's down here. The coordinate is 0, -1. If cosine is my x coordinate, that means cosine of 270 would be 0. Sine of 5 pi over 3. Sine of 5 pi over 3. So 5 pi over 3 is the same as 10 pi over 6. So 5 pi over 3 is here. And that's a 60-degree reference angle, so my coordinate is 1/2, and then -√3 over 2. So my sine would be -√3 over 2. Tangent at pi over 6, well, pi over 6, that coordinate is √3 over 2, 1/2. So we're doing 1/2 divided by √3 over 2. You'd end up with 1 over √3, which you have to rationalize, so it'd be √3 over 3. Sine of 7 pi. Well, that is a coterminal angle, so I'm going to keep subtracting 2 pi until I get something on the unit circle. So sine of 7 pi is the same as sine of pi. Well, at pi, my coordinate is -1, 0, so sine would be 0. Tangent at 2 pi over 3. So 2 pi over 3 is here. Nope, it's over here. So my coordinate would be -1/2 √3 over 2. So if I'm doing y over x, I would get -√3. Cosine of -pi over 4. So -pi over 4 would be here. So cosine would be -√2 over 2. All right, tangent of -3 pi over 2. Well, that would be up here, and that coordinate is 0, 1. And so that means if tangent is y over x, that'd be 1 over 0, which is undefined. Cosine of 480, so I'm going to subtract 360. So I'm going to have cosine of 120 degrees. 120 degrees is right here, and it'd be -1/2. Cosecant of 180, well, at 180, my coordinate is -1, 0. Cosecant is the reciprocal of sine, so 1 over 0 would be undefined. Secant, so that's the reciprocal of cosine at 4 pi over 3. So that coordinate would be -1/2, -√3 over 2, and I'm taking the reciprocal of the cosine, so it would be just -2. Cotangent at pi over 4. Well, at all the pi over 4s, we know our coordinates are √2 over 2, √2 over 2. So when you divide those by each other, you get 1. Or if it's in quadrant 2 of 4, you get -1. Cosecant is the reciprocal of sine, so sine at 5 pi over 3 is negative root 3 over 2. So the reciprocal of that rationalized would be negative 2 root 3 over 3. Cotangent at negative pi over 6 is same as 11 pi over 6, and my coordinate there would be root 3 over 2, negative 1/2. And my cotangent is x over y, so it's just going to be negative root 3. Cosecant at 315 is negative root 2 over 2 is what the sine would be there. So we're doing the reciprocal, it's just negative root 2. Cotangent at negative 3 pi over 2 is the same as at pi over 2. The coordinate is 0, 1. Since it's x over y, it'd be 0 over 1, which would be 0. Secant, we're going to reference cosine at 210. Would be a 30-degree reference angle. And so my cosine is negative root 3 over 2 because I'm in quadrant 3. So if I rationalize that, it's negative 2 root 3 over 3. All right, so now we're going to go the other way. Now they're giving us a value. We need to state what angles in radians satisfy for negative 1. So when is cosine negative 1? Well, cosine's only negative 1 at 180 degrees or pi. When is sine, or when is y negative root 3 over 2? Well, sine is only negative in quadrants 3 and 4. And if it's your sine, that means it's the pi over 3. So it's going to be 4 pi over 3 and 5 pi over 3. Tangent is 0. Well, tangent is y over x. So the only time tangent would be 0 is if y is 0. Y is 0 at 0 and pi. It's also true at 2 pi, but notice how it doesn't equal 2 pi, so it's only up to 2 pi. All right, cosecant of root 2. So this is when sine is root 2 over 2. So sine is positive in quadrants 1 and 2. So that would be at pi over 4 and 3 pi over 4. So if the secant is undefined, that means my cosine was 0, which is true at pi over 2 and 3 pi over 2. So the cotangent is x over y. So this is a rationalized, so that means my root 3 over 2 was in the bottom and my 1/2 was in the top, and only one of them was negative, so that's in quadrant 2 or quadrant 4. So my x is 1/2 in quadrant 2 at 2 pi over 3, and in quadrant 4 at 5 pi over 3. All right, now we're going to talk about how we express theta for all radians, meaning how do we basically say it's this and every single coterminal angle related. So cosine of theta equals negative 1/2. So let's think about the unit circle. Cosine is negative in 2 and 3. So that would occur at 2 pi over 3 and 4 pi over 3. But now to say that we want all, we're going to say where k is any integer. And so we're going to say 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. And so k could be positive or negative, and so that's how we're going to add or subtract 2 pi from each of those values to show that it is that value at all of those coterminal angles. So we're going to do this for everything. And so we'll make a little note for sine and for cosine. We're going to add 2 pi k. For tangent, we only need to add pi k, and that's because tangent repeats itself every half of the unit circle versus sine and cosine only repeat themselves every one time a unit circle. I'll show you what I mean when we get to a tangent problem. So sine of theta equals 0. So sine is 0 on the unit circle at 0 and pi. So in this case, actually, this is one of the only ones where it works out like this. So I would say 0 plus 2 pi k and pi plus 2 pi k. We could also have just written it as 0 plus pi k. But either way, that works. All right, so tangent is sine over cosine. So if it's negative root 3, that means my y is root 3 over 2, and my x is 1/2, and it's negative, so one of them is negative. Tangent's negative in quadrants 2 and quadrants 4. So this would be true at 2 pi over 3 and 5 pi over 3. So I could say 2 pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. But notice that 2 pi over 3 and 5 pi over 3 are actually only 5 apart, or only pi apart, sorry. Because pi is the same as 3 pi over 3. So you could also write this as just 2 pi over 3 plus pi k. In 26, where is my sine 1? Well, that's at pi over 2. So there's only one answer for this one. Pi over 2 plus 2 pi k. 26. So cosine, so this is a rationalized value. So basically, when is the cosine root 3 over 2? Cosine is positive in 1 and 4. So that means it would be true for pi over 6 and 11 pi over 6. So pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. All right, where's the cotangent undefined? So that means if I did x over y, the denominator was 0. So 0, 1 would be at 0, or also at pi, because in theory it could be negative 1 over 0. So 0 plus 2 pi k and pi plus 2 pi k, or again, those are only pi apart, so I could just say 0 plus pi k, because there's more than one way to write that. All right, we're going to simplify some of these expressions by inserting the unit circle value. So cosine at 2 pi over 3 is negative 1/2. Cosine at pi is negative 1. Sine at negative 5 pi over 6 is the sine at 7 pi over 6, which would be negative 1/2. And then sine at negative 3 pi over 2 is the same as sine at pi over 2, which would be 1. So it's going to be 1/2 plus negative 1/2, which would be 0. 5 times the tangent at 3 pi over 4. Well, 3 pi over 4, any of the 4s, we know that our coordinate is root 2 over 2, root 2 over 2. So tangent is either 1 or negative 1. Since it's in quadrant 2, that means tangent's negative, so tangent would be negative 1. Tangent at 4 pi over 3, well, 4 pi over 3, my coordinate is negative 1/2, negative root 3 over 2. So y over x would give me an answer of root 3. So I'm going to have negative 5 minus, well, root 3 times root 3 is 9, root 9, which is 3. So negative 5 minus 3 would be negative 8. Are the following values positive or negative? All right, sine of 2. So 0, this is 3.14. So 2 is somewhere between there, and sine is positive in both those quadrants. So we're going to say this would be positive. Cosine at 4 pi or 5 pi over 4 would be in quadrant 3, so it would be negative. Tangent at negative 1.2. Well, that would be in quadrant 4, and tangent is negative in quadrant 4. All right, assume the terminal side of the angle of t radians passes through the given point. Find sine, cosine, tangent. Okay, so we know that x is cosine and y is sine. So this would be 5 over 13. This would be 12 over 13. We know tangent is y over x, so it would be 5 over 13 divided by 12 over 13, which would end up being 5 over 12. You could also think about these as a triangle, and that you know your hypotenuse is 13, you know your x is 12, and you know your y is 5. Tangent would be opposite over adjacent, so it would be 5 over 12. That's another way you could think about it. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Tangent is the reciprocal of cotangent. And so that's how we get those. Similarly, I could draw a triangle. This one, the y is negative, and it should be actually be in quadrant 4. Again, so you could use your SOHCAHTOA if you want, or use what we know about unit circle. So sine is y, cosine is x, and you don't need to rationalize these. It doesn't matter to me. Tangent is opposite over adjacent, so it would be negative 2 over 5. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent.